Okay, we're going to once again look at Newton's second law. In this case, it's still a known acceleration, and it is an elevator problem. Once again, I will remind you that to get the best result out of doing these problems or going through them is to pause the video wherever I ask a question or ask you to do a calculation. Try your hand at either answering the question or doing the calculation before you actually see the answer. All right, we're given that the elevator is accelerating upward at an acceleration of 3 meters per second squared, and we're asked to find the scale reading. First thing you want to do is let's draw a free body diagram of the forces on the person. So take a minute and do that. I show you the free body diagram with the normal force pointing upward on the person. That is the force the scale exerts on the person, and the gravitational force on the person, which is the mass times the gravitational acceleration. And beside the free body diagram, I give the acceleration as 3 meters per second squared. Next, I want you to write Newton's second law for the person. Newton's second law is simply the sum of the forces, or the net force, is mass times acceleration. In this case, we know what the acceleration is, this number here. That is given as our 3 meters per second squared. So we have that the normal force in the positive y direction minus the gravitational force in the j direction is equal to mass times acceleration in the positive j direction. Now, answer the question, why do I not need to put my vector signs here? So what is the unknown? Well, the unknown is Fn, the normal force, because the normal force on the person, or that the scale exerts on the person, is the force that the person exerts on the scale. Remember Newton's third law. And so we want to find this number here, Fn, normal force. Well, let's go ahead and put in the numbers. Normal forces are unknown, minus the mass times the acceleration due to gravity has to equal to the mass times the acceleration of the elevator. And we find out, after plugging in and solving, that the normal force is 1,088 newtons. What does the scale read? Well, if that's the normal force, based on Newton's third law, we know that that will be the force that the scale reads, 1,088 newtons.